Hello students, welcome to Unit 5 Notes, Section 7.3. The warm-up is super quick today. I'll just explain each one. So name the postulate or theorem you can use to prove the triangle's congruent. This one is by the side postulate. Here we have side angle side with an angle included in between the sides, and then we have angle side angle for these two with the side included between the two angles. So today we're going to be proving triangles similar, not congruent, right? These were congruence ones. These were congruents. The rest of these are the ones we're doing today are about similarity. So we have three similarities. We have angle-angle similarity, we have side-angle-side similarity, and we have side-side-side similarity. Okay, we're going to apply all three of these and write similarity statements. And we'll even do some real-world application involving indirect measurements. So the three postulates, I put them all right here. We'll go one by one. The first one is angle-angle similarity. Because we have one angle congruent to another angle, we have this pair congruent to this pair. We have P congruent to T, L congruent to R. What we know, if two are congruent, the third ones have to be congruent for angles. So this is just a dilation. TRS is smaller, but when dilated larger, we get PLM. Now, we only need to use the least amount of information possible by also it meaning the most. So what this one is just simply the angle-angle similarity. Okay, we don't say angle-angle-angle similarity, just angle-angle similarity. So here, TRS is similar to PLM. TRS is similar to PLM because of the angle-angle similarity. So this is the first one I look for. I look to see, hey, do these two triangles have two congruent angles? If so, boom, they're similar. I know right away. Now let's say I don't have two angles, but I have two sides. Well, we can definitely use a side angle side. It might be a little bit more difficult, but here's what happens with a side angle side similarity. If an angle of one triangle is congruent to an angle of the second, and the sides including them are proportional, then the triangles are similar. So let's just take these two triangles because we know that they're similar already, but I'm just going to copy them over. And let's copy one set of angles. I'll do this one. Okay. And I'll name this one A, B, C, and D, E, F. Okay, let's take it and move it. Okay, so we know that these are almost similar. We have one angle, but what we need now is our proportional sides. So I'm going to say this side is 6 and 8, and let's do 6 and 8, and I'll do 2, 4, 6, 8, 3, 6. Let's do 9. No, let's do 10 and 15. All right, so what I need to do, the first thing I state is that angle D, I say angle D, angle A is congruent to angle D, and then I take 6 over 8 and I see if it's equal to 10 over 15. And, oh, I messed this up. Let's do Oh, 2, 4, 6, 8, 5, 10. Let's say 15 and 20. My bad. And so I'm going to change this to be 15 and 20. So I can either simplify these fractions or find the cross products. And so if I simplify them, I'll get 3/4 and I'll get 3/4. And what I proved is that DF, AC is to DF as AB is to DE. I demonstrated that they were proportional. So you got to take these sides that have the angle included and you prove it proportional. And so now I can say that triangle ABC is similar to triangle DEF by the side angle side theorem. And the last one is the side 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 theorem. So we're going to have to take, let's take these same triangles. I'll rename them. I will rename them. Again, we don't have angles now. So what are we going to name it? We will name it RST. Is that the ones up here? Oh yeah, RST has already been used. EF. Let's go. GHI, GHI, and J, K, and L. And so for these, we'll do what, 6 and 15. We'll do, let's do 24 and 32. All right, so for this one, I'm going to see is 6 to 8, is that equivalent to 15 to 20, and is that equivalent to 24 and 32? And we have 3/4, we have 3/4, and then 8, 16 plus another 8 is 24, 3/4. And it looks like they are all similar. So what we did was we proved that IG is to LJ as GH is to JK as HI is to KL. And we proved that they were all proportional. So if you have three sides that are proportional, you can claim by the side similarity. You always have to use that symbol similarity, that they are similar. So IGH is similar to JKL. Oh, wait. What did I do? I should say GHI. My bad. GHI is similar. Triangle GHI is similar to, that looks weird. There we go. Is similar to JKL. All right, so those are our theorems. So that's all we need. We either need two angles. That's my checklist I go through. First, I check for two angles. If I don't see it, I look for one angle and I pick the sides. And then if not, I do the side. So using the angle postulate, well, here we know that this is 45 degrees and this is 45 degrees. Oh, look at this. We have vertical angles. So we know vertical angles exist. We know that those are both 45 degrees. Then we are going to say WRS, triangle WRS is similar to triangle BRS VS by the angle-angle similarity theorem. Oh, well, in that case, I think postulate. Right, the first one they call postulate. Yeah, it doesn't really matter. I mean, it does, but not for what we're using this for. Okay, in example 1, do you have enough information to write a similarity statement? Do you have enough information to find a similarity ratio? We have enough info. We have enough information to write the triangle similarity statement. But we do not have enough info to write a similarity ratio, or to find. Right? But we don't have any sides. We don't have any sides, so we don't have any lengths to be able to write that. Okay, the second one. All right, looks like we have angle Q is congruent to, angle R is congruent to angle Y. So that's my first piece of information I need. Now I need to determine proportional sides. So I'm going to do 3 over 4. Does that equal 6 over 8? And again, you can simplify these or cross product them. I'm just going to simplify them like this. 3/4 equals 3/4. So I proved that we have QR. QR is to XY as RP is to YZ. So those are my two sets of proportional sides with the so here's my two sets of proportional sides. Here are my congruent angles. So I'm going to say, I'm going to say triangle QRP is similar to triangle XYZ by the side angle side similarity. And I'm going to say the ratio is 3:4. All right, explain why the triangle must be similar. This one we are going to do, we'll take our 6s with our 8s. Doesn't really matter the order for these. And then we'll take our 9 over our 12. And so 3/4, 3/4, 3/4. So I proved that A, C, CB, BA, I proved that AC is similar to, let's see, what could I say, EG, and then CB, so I'm doing down the 6, down the 6, down the 9, so you go down the 8, down the 8, down the 12. So GF, and then FE. This is weird. I could have gone this way and this way, and I could have gone left to right as well, or could have gone right to left. Doesn't matter. I could have gone down the 9 and then gone in either direction. So down the 12, down the 8, down the 8, down the 9, down the 6, down the 6, or down the 9, down the 6, down the 6, because the side lengths were both the same length. So I have that information. That's what I needed. So now I can say that triangle ABC is similar to triangle EGF. And by the side similarity, and they are ratio 3 to 4 as well. All right. Finding lengths in similar triangles. So we know that these are similar. So what I need to do is I need to see how they're similar. So I need to find their ratio. You might be tempted to do 12 over 24 and 16 over 18, but let's pick this smallest side, AB, and see how it's where it gets connected to. Here is 18. These are the smallest, 12 and 18, and 16 and 24 will be the other ones that match up. All right, how do I know this? Because this angle that exists right here would refer me, because I know that the angles are congruent by the vertical angle theorem, would force me to use the sides that include those angles, which is why I'm doing this. So 16 is to 24. Well, the ratio here, it's a 3 to 4 ratio, but that should also mean that 10 would relate to an unknown over here. So 10 is to x. Now, I can pick either one of these, but I will solve this probably just by doing the cross products. That would make this easy. 16x equals 240. Oops. So divide both sides by 16. And I'm doing that right now. 240 divided by 16. Yep, is 15. So x would have to be 15. All right. And 15 is one of the answers. And take a look. Every one of these, we are doing 2 to 3 ratio. So for a, sorry, what am I looking at here? 6, 12, 18, 8, 16, 24, 5, 10, 15. So everything was in 2 to 3 ratio. Find the value of x in the figure at the right. So here we have angle, angle. So we are going to take, we'll take this number here, that's 6. That's between 1 and the 2 tick marks. And I'll take x, which is in between the 1 and the 2 tick marks. And I'll take 8, which is across from the 2 tick marks, and I'll set that proportional in ratio with 12. And I'm just going to find the cross products. So 8x equals 72 divided by 8. 8 times 9 is 72. So we'll get 9. Yep. And if we were looking at this 4, 8, 12, 3, 6, 9. It's in 2/3 ratio. Okay, applying angle, side, and side similarity with indirect measurement. So let's say we can't necessarily measure something like this cactus. We don't know the height of this cactus. What we do know is that the sun is above this person and this cactus, casting the same type of shadow with the same degree measure from where the sun is. So what we do know is we know that this angle here is congruent to this angle here, and really this one down here, what's found against the sun and the shadow, is also congruent. So really we have two similar triangles here, and we're going to use indirect measurement to find that. So it says one method of indirect measurement uses the fact that the light reflects off a mirror at the same angle at which it hits the mirror. A second method uses similar triangles that are formed by certain figures and their shadows. So here we have this particular, we know that these triangles are similar by the side, no, sorry, by the angle similarity. Okay, and we're going to say that 6 is to x as 4 is to 9. And we're going to do the cross products. We will get 4x, 6 times 9 is 54. So 54 divided by 4. Yep. So we're going to divide both by 4. We get x equals 13.5 feet. And so the height of the cactus is 13.5 feet tall. All right. And if we were wondering, I mean, does it make sense? 4 times 2 and a quarter would get me this. 6 times 2 and a quarter gets me 13 and a half. All right, the next one. Here we have a geyser, and it says Raymond places a mirror on the ground 40.5 feet from the base of a geyser. He walks backwards until he can see the top of the geyser in the middle of the mirror. At that point, Raymond's eyes are 6 feet above the ground, and he is 7 feet from the image in the mirror. Use similar triangles to find how high the geyser is, and well, let's take a look. He is 6 feet looking downward. We have angles here that are, so I'm going to draw in this because it's a little bit easier to see when I draw it with this ink. We have by the angle similarity. Okay, we have by angle similarity. And what we're going to do is we are going to say 6 is to x because we have to match the pieces. This is across from the 1 tick mark. So I have to go over here and find the 1 tick mark as well. So 6 is to x as 7 is to 40.5. So as 7 is to 40.5. So I'm going from triangle to triangle to triangle to triangle. I'm jumping back and forth. And I'm going to do, so this is 7x equals 243. Let me just check my work. So 40.5 times 6 is 243 divided by 7. We're going to say x is approximately 34.71, let's say 31.7 feet. So the geyser Geyser is 34 is about 34.7 feet tall. right. That's it. If you want to make this into inches, you would take your 34 way in your calculator and get 0.714, blah, blah, blah. And you just times that by 12, and that would give you 8.5 inches about. So it's about 34 and 8.5 inches tall. Well, we can leave it exactly the way it is. So I'm going to end it here. We'll do these notes in class, and good luck with IXL and answering this in class.